$70,000. One propeller drone. And it is forcing $4 million interceptors to rewrite modern air defense math. Everyone assumes Russia built this weapon. It did not. Iran designed it for a regional conflict the world ignored for years. Most call it a kamikaze drone. That description misses the point entirely. The Shahed is a pricing weapon with wings attached. This documentary explains how one Iranian airframe simplified by Russia collapsed the economic logic behind every modern air defense. The Shahed 136 entered Iranian service in 2021, without Western analysts noticing the true design intent. HESA built the platform around one principle: make the airframe so cheap that destroying it costs more than replacing it. The Delta wing uses fiberglass over carbon honeycomb, reducing radar return and pushing production costs down to industrial scale. The engine is a Mado MD-550, an Iranian copy of a German Limbach 50-horsepower piston motor from the 80s. This engine was never military grade. It was designed in the 1980s for civilian ultralight aircraft across the rural German countryside. Iran obtained the engine blueprints through ordinary civilian trade channels, then reverse-engineered the motor at HESA using rough commercial tolerances. The guidance system runs inertial navigation plus GPS and GLONASS, all built from off-the-shelf civilian parts sourced globally. 90% of the electronic components inside a Shahed originate from Western manufacturers, sold openly as legal civilian parts. Texas Instruments and Analog Devices chips have all been recovered from downed Shahed wreckage after repeated Russian strikes on Ukrainian power grids. The original baseline warhead carried 50 kilograms of high explosive, packed into a precision-machined steel casing at the airframe nose. Maximum range exceeds 1,000 kilometers, with cruise speed locked at 185 kilometers per hour under continuous piston power. The Iranian Shahed launches from a simple truck-mounted rack in open fields, without aircraft support, missile silos, or fixed launch facilities. A solid rocket booster fires the drone off the rack, then falls away seconds later as the pusher-mounted propeller takes over for cruise. Cruise altitude stays below 2,000 meters, sitting inside the clutter layer that conventional ground radars cannot resolve precisely. The Delta wing is deliberately oversized for the airframe weight, generating enough lift to allow flight at minimal sustained engine power. Low power consumption means extended flight duration. Extended duration means the drone can cross 1,000 kilometers on one fuel load. The trade-off is speed. At 185 kilometers per hour, the Shahed flies slower than a typical civilian aircraft. Slow speed makes it vulnerable to fighters and patrol helicopters, but the low radar signature makes detection unreliable at combat engagement range. Guidance is the weakness defenders exploit most often. Civilian GPS signals can be jammed or corrupted using cheap jamming hardware. Russia solved this by replacing Iranian navigation with Cometa M antennas, using up to 16 elements for anti-jamming filtering. The anti-jamming module uses one FPGA and 3 microcontrollers to identify and suppress hostile radar jamming in real time. Warheads evolved across iterations. 50 became 90 kilograms. Tandem and thermobaric variants followed with tungsten fragments. The 90-kilogram variant effectively doubled warhead mass by reducing internal fuel, cutting range to around 650 operational kilometers. Thermobaric warheads create pressure waves, destroying soft structure interiors across hundreds of cubic meters in one blast. Shaped charged tandem warheads first appeared in 2025, allowing the Shahed to penetrate light armor and reinforced concrete power substations. None of this hardware is advanced. The Shahed is not the innovation. The production architecture behind the drone is the innovation. The real story behind this drone starts with the price tag. Not the airframe, not the engine, not the warhead engineering at all. To understand how cheap weapons are reshaping modern air warfare, subscribe. We break down one military system per documentary. Iran originally sold Shahed assembly kits to Russia at $370,000 per unit in the earliest industrial batches. Bulk orders changed everything. The unit price dropped to $193,000 across 6,000 industrial-grade units. Then Russia localized production. At the Alabuga Special Economic Zone, unit cost compressed to $70,000 by 2025. Analytical estimates go lower, $20,000 to $50,000 per unit, depending on configuration and warhead variant. A single Patriot PAC-3 interceptor costs $4 million. Shooting down one Shahed can cost 50 times the drone itself. Alabuga now manufactures 5,000 Shahed drones per month, with plant capacity approaching 5,500 units. by 2026. Close to 60,000 Iranian Shahed drones have hit Ukraine since the very first Kiev strike, back in October 2022. 90% of the electronics inside every drone come from Western companies, sold openly through legal civilian distribution networks. Component supply chains route primarily through Turkey and Kazakhstan, before quietly reaching Iranian and Russian assembly lines. Western sanctions cannot block these parts because they are commercial. The same chips shipped to thousands of legitimate weekly buyers. The drone itself is simple, but the industrial system producing it at scale, that is Iran's actual military weapons platform. The airframe is just the delivery vehicle. The real weapon is the cost structure behind it. And this is why the Shahed matters strategically. No defender sustains $4 million interceptors against $70,000 attackers. The math breaks before the battlefield collapses. Combat use started in Ukraine during the autumn of 2022. The first wave struck Kiev with crude Iranian baseline airframes. By early 2023, Russia had begun producing its own military variant, the Jiran 2, with reinforced airframes and improved navigation. Evolution came fast. Tungsten fragmentation and 90-kilogram warheads arrived alongside black paint and Kometa anti-jamming modules. Then came the jet variant. The Jiran 3 mounted a turbojet replacing the original piston motor, based on the Shahed 238. Cruise speed jumped to 500 kilometers per hour. That cut defender warning time in half, across identical flight profiles. Specialized variants followed. R-60 air-to-air missiles and Verba manpads mounts appeared, alongside FPV carrier airframes. Russia began launching decoy drones. Gerbera and Parodya foam airframes cost around $10,000 and mimic radar signatures convincingly. 40% of Russian drone launches are now decoys, forcing Ukrainian air defenses to fire on cheap plywood airframes. From 2025 to 2026, Russia deployed 19,000 Shahed drones across Ukraine in 90 consecutive days. February 26, 2026, Ukraine faced 459 simultaneous threats across 5 separate weapon categories. Ukrainian air defenses intercept close to 90% of incoming Shaheds. The remaining fraction still reaches infrastructure and civilian targets. At current volumes, 10 to 15% leakage means dozens of warheads reach their targets during a single 500-launch operational night. 90% interception sounds like victory. The math says otherwise. Saturation defeats precision when volume breaks the cost curve. Shahed operational doctrine is now proven across multiple theaters: Ukraine, the Red Sea shipping lanes, and the South Caucasus. 3 military powers now operate reverse-engineered Shahed derivatives across active fleets: Russia, Iran, and the United States military. In December 2025, the Pentagon announced Lucas, a reverse-engineered Shahed clone built for the United States military. Ukraine fielded its own Shahed analogs by mid-2025. Patriot and Artemis ALM-20 followed in operational service. The doctrine has been adopted industrially. Cheap one-way attack drones at mass volume. That is the new baseline of modern military strike warfare. Existing air defense stockpiles cannot absorb this volume forever. Patriot and SAMPT systems are too expensive for sustained Shahed interception. Cost asymmetry forces adaptation. Defenders must build interceptors as cheap as the threat, or accept the saturation breakthrough. Ukraine built 100,000 interceptor drones in 2025. Those drones scored 70% of operational Shahed kills by January. Directed energy weapons are now in accelerated development. Lasers can intercept Shaheds at near zero cost for every intercepted target. The Shahed 136 succeeded not by being advanced, but by being impossible to stop economically across long strategic campaigns. This is what changed in modern air war. Expensive military defenders lose when the production gap widens faster than the interception gap. Iran designed the platform. Russia industrialized it. The Pentagon is fielding its own version. The doctrine has crossed every major military. The Shahed is not the most dangerous drone ever built. It is the most economically disruptive weapon ever produced at industrial scale. The asymmetry is not going away. Every major military is now building cheap one-way drones and cheap interceptors to counter them. The next wave is already visible. Laser defense, microwave denial, and autonomous interceptor swarms are replacing Patriot for saturation defense. The defender that adapts fastest to cheap mass wins the next decade of military air warfare. The defender that cannot adapt loses by default. And the system reshaping that defensive math is already flying across Israel and the Gulf. The next documentary covers Iron Beam,